My name is Michael Plannerer. I'm from MEN Micro Germany, and I'm there as the Director for Global Research and Development. So I'm responsible for all software, hardware, and mechanical perspectives at MEN. So today I would like to talk with you about virtualization technology. Mainly we are in the railway business, so I can tell you a little bit how a train looks like at the moment and how a train could look like in the future. So what do you think? What is the typical wishes from a train operator? For sure, he's interested in satisfied passengers. He's every time looking for reduced system costs. He's also searching for scalability solutions, highest performance he can get. Also in the meanwhile, you see a lot of requests for security and safety features. Also energy efficiency is a must in the meanwhile. On one hand side for a small system, and the other hand side for a total train. Also, the topic about maintenance is really important inside the train because it's hard to get there and you have to have 24 hours uptime. So easy maintenance is important. Also, the terms about long-term availability. What does it mean in a train? At least 15 years availability for a system. It's a quite long time. If you have to provide newest architecture for 15 years, it's challenging. Normally, they're expecting at least 30 years. And also terms about highest availability are a must. And so every time asking about supply independence. So I would like to show you some typical applications in a modern train. So energy management is a really nice and important thing because you would like to have fuel efficiency. So you have to do something. Also driver assistance is really a must because you would have a safe system in a safe train. Entertainment from passenger is also a must in the meanwhile. Surveillance systems are also a topic for safety reasons in a train. Passenger information is also a nice feature to see the next stop of a train. It's a must. Also internet on board is definitely in the meanwhile a hard request. Ticketing, normal feature in a train. So if you look about all the things, you have at least 8 units. That means 8 times computing, 8 times local storage, 8 times power consumption, 8 times a bad MTBF, and so on. So you have a lot of challenging things you have to solve. So now I would like to show you a solution which could make train operators really happy. So our idea is quite simple. Simply use IT infrastructure like you know from your company. So what are normal things in a company you have? You have a lot of servers, you have storage systems, you have a big and a nice network, and sometimes you have some kind of I/O extensions. That's the same things we need in a train. So now you can see a possible architecture from IT-based train infrastructure. So in the middle of a train, you see a big Ethernet switch. Typically, you have ring protocols on it, so you have a definitely available system in a train. Normally, you do I/O extensions directly via Ethernet, so you do not have to have additional cables inside. You have one main server and you have a storage system. As I mentioned, availability is also a must. So in that example, we added a second server and a second storage system. So now let's start with the voodoo magic. So as I mentioned, 8 times a box. It's a current application, so you cannot touch it. You have an operating system. No, you have 8 operating systems. You have a Linux, DOS, and so on. You have dedicated hardware, old PowerPC, modern x86, so a total mixture of that. So how we can consolidate all that things together to a new architecture? That's the main question. I have the answer for you. Voodoo magic. Now I think it's a little bit easier on that point. So the main idea behind is virtualization. It's quite easy, so I would like to tell you a little bit the difference about virtualization and will show you afterwards how we do it in detail. So at the moment you will find 2 types of hypervisor on the market, type 1 and type 2. So the big difference, you can see it here. So the best implementation of a hypervisor is definitely the type 1 type. So you're running this hypervisor directly bare metal. That means directly on your hardware, the hypervisor is configuring the hardware and is providing all the necessary APIs to the different operating systems. So all operating systems are directly running on the hypervisor. There's a second architecture available. So it's called Type 2. On a Type 2, you have a basic operating system. On that operating system, you have a running hypervisor on it as an application. And that hypervisor also provides you all the necessary APIs for your dedicated operating systems. So what are the benefits or the difference between both types of implementation? On the one hand side, Type 1 provides you the best performance you can have because you have direct access through the hypervisor to your bare metal hardware. So it's quite nice to have it. But there's also a big lag. You have to port all your drivers for a bare metal hypervisor. So it's not funny. So you will get from your vendors typical drivers for Windows, Linux, and so on. But you will not get a driver for Xen something. So it's not so easy to do. So the other thing is try to use an operating system like Linux, like a Windows. Use all the drivers and bring your hypervisor application on it. But you lose a lot of performance. So typically you find some mixture things on the market in the meanwhile. So typically thing for that is Linux, and there's a KVM extension inside the kernel. The nice thing on that is that KVM is directly part of the kernel and it's mainline. So each kernel update will provide you also the updates for the KVM engine. The KVM part is directly running inside the kernel. So you have the benefit of a bare metal implementation because it's directly running on the kernel, so directly running on your hardware. On the other hand side, you have a total Linux system. So you can use all the drivers you will find on the market definitely inside that Linux environment. So if you read a little bit of articles about Linux KVM, you will find, oh, it's a Type 1, oh, no, it's a Type 2. I think there's no hard decision. Find your own way if it's a Type 1 or Type 2, but I think it's a nice solution. So now let's talk a little bit about how you bring your existing operating system, your existing application to a virtual machine. So on the left-hand side, you see a real-time operating system. It's running in one virtual board, I would say. For that, you have simple I/O, so you have Ethernet, you have one core, you have a little bit of memory, and some timers. So quite easy, but that's all packaged in one virtual board, and that's running on a hypervisor. On board 2, you have running a regular Linux. You can simply get it from a normal board, bring that to a virtual machine, and run that on your hypervisor solution. For that you do not have to modify it, you need an IDE interface, your COM interface, Ethernet, and so on. So you should not see a difference between your real hardware, your real I/O, and the virtual machine. That's the trick behind. All that is running in a hypervisor, and that's running on a physical board with all the Ethernet interfaces, HDD, and a lot of cores. So you heard a lot of things about virtualization. But are there other things? Yes, there are other things. So virtualization light, I think it's a good name for that. It's something in the middle. Maybe you heard about containers. Containers is quite simple. You're near the harbor, you will see containers. So what's the trick behind? It's standardized. So every time the same outlines, the same dimensions, so it's quite easy to exchange one container with another one. That's the same trick behind containers in a Linux or in that environment. So on the left-hand side, again, you see hardware, operating system, your hypervisor. On that, you have your operating system 1 with libraries for your application and your application. I have, in that example, 3 times. So you have 3 times your operating systems. So you need at least 3 cores. You need at least a lot of memory. But you have your separation. It's a nice application, so it's good. On the right-hand side, you see another approach. We have, again, hardware, our operating system, and our engine for containers. The best available solution for that is Docker. Docker is a standardized engine for container architectures. Also, Microsoft brought that to their server operating system. So you can run Docker also on a Linux or a Windows environment. So now you can see the biggest difference between that architectures. So you do not need an operating system for that. So separation is done inside the containers. Separation is not so strong like a virtual machine because on a virtual machine you have 3 times operating system. On a container you have only blocked applications plus the library. So all the things you have to have running on an application, you will have that inside a container. So you can simply exchange one container by another one. or do a reboot and so on. So all the things are available, but you do not have operating system, and so you save a lot of resources. You do not need a lot of cores, you do not need a lot of memory. So it's a nice approach, but you have to do a little bit on software side, so it's not so easy to port really your available solution to a Docker container. So you have to do some things. Okay, so now let's talk about a little bit how we can add I/O infrastructure in a train. Okay, so on the left-hand side, again, our main server. You have seen it already. We have a local I/O, like storage systems, like wireless interfaces, we have it. And also some binary I/O, but it's not important in our example. The simple way to extend that is to use an Ethernet switch, as I mentioned. So Ethernet is quite simple, it's available, it's well known, so it's nice. We will add, in our example, on that Ethernet interfaces, a panel PC, a little bit I/O, additional storage system, and also wireless interfaces. So now you will ask, what I have to do in software? What is the difference between centralized and not centralized? I will show it to you. So now you can see a total abstract hardware environment. So on the bottom line, again, our hardware system. You have your hypervisor, in our example, the KVM. Running on top of that, we have a virtual Ethernet switch. That switch provides you all communication passes between virtual machines. The normal way to do communication in a virtual environment is Ethernet. So you have virtual Ethernet controllers inside each guest operating system. And so it's quite easy to do communication between your virtual machines and your main Linux system. On the right-hand side, you see an additional nice feature. At that point, you have a chance to bring I/O directly to a virtual machine. Well, it's necessary, mainly for security purposes. For example, if you think about a wireless interface, there could be a lag in the driver, so it's hard to secure the driver. So it's much easier to bring exactly that driver to the virtual machine. With some additional I/O extensions in a processor, you can bring that I/O directly in a virtual machine, and so you have a secured environment because each I/O access is directly made to the virtual machine, not to your main Linux system. The normal way out of that is definitely to do it via Ethernet. And so it's quite easy also to do the same things like in a virtual environment with an additional firewall. So you can add simply a firewall, for example. So you have Ethernet communication, you have a direct access from the wireless interface to the outside world, and so you have a real secured environment together with your virtual machines. So what could be possible on top? So we are talking about a little bit virtualization. So it's nice, but I think it's not the top end. On the top end, you will see cloud solutions like Amazon Cloud. Amazon Cloud is built with OpenStack technology. So how a real good or big cloud could look like, I will show it to you. So in the middle, you have a lot of virtual machines. For each service, you have a virtual machine, like your web server, your storage system, and so on. So what do you need for that? You need configuration tools. It's quite simple. There are pre-configured configuration tools for that environment. It's much easier to do configuration via graphical user interface. So you can simply add services for graphical user interfaces. Also, monitoring is really important to have a real available and nice running system. Typically, security is an issue, so authentication on a system is normal and is important. So there are also available services for that. You would like to control your resources, so you have to split up your processor performance, your memory usage, your cores, and so on. There are dedicated services to provide all the computing things to the virtual machines. You would like to boot your service, so you need a server for images. So it's also available in that environment. You would like to store local data, so you have a block storage environment that you can save, for example, movies also inside such a system. As I mentioned, all the communication is done via Ethernet, so you have software-defined networking. So it's quite easy also to extend to have centralized, decentralized I/O. And also load sharing is a really important thing, because at the moment do not know which service needs your resources. So it's much easier to have limited number of resources, and you can shift out your resources from a web server to a booking system and so on, because you do not need the same performance at the same time. So load sharing is a nice way to save a lot of energy. So that is the on-top solution you can have, but it's also a lot of work to do configuration for that. So let's do a little bit summary about that. So virtualization provides you a nice scalability. It provides you the best performance you can have in such an environment. As I mentioned, you have a really good chance to do secure communication. So you can bring your wireless interface in a virtual machine. You can add a firewall. You can make all the things happen. You have only one main server and a storage system. So maintenance is much easier. You do not have to deal with 8 or 10 or 20 systems in a train. So it's much easier if you do maintenance only for one server. You can do hot standby and such things. So you have really nice possibilities for maintenance. You do not have dependencies on your hardware. You do not have dependency on your I/O. So you can simply exchange that because it's all virtualized. It's not real. Only the last end physical interface is real, but that's the only point. So definitely have reduced costs. If you think about eight systems, 8 times the power supply, 8 times cooling, housings, and so on. So it's much better to have only one big server, like the C&D you have heard today. So it provides you up to 16 cores in such an environment. If you have to pay 8 times for a smaller CPU, you will pay much more money instead of having one big server environment. And also the energy efficiency is much better, because if you have 8 processors, you have definitely more computing power and power consumption compared to a server environment. And also with all the things like load sharing, like redundancy, you can reach all the things like high availability and also long-term availability.